Hello students, and welcome to this lesson on interior and exterior angles of polygons. Our objective is that we will write conjectures about the sum of interior and exterior angles of polygons using journal notes and examples. So let's go ahead and analyze that objective. So we will write conjectures about the sum of interior and exterior angles of polygons using journal notes and examples. So conjectures, what are conjectures? Well, conjectures are statements, right? Those are statements about things that we believe to be true because of the evidence. So we're writing our statements, evidence-based statements, about the sum of interior and exterior angles of polygons using journal notes and examples. So first off, we need to know these different types of polygons. So let's go ahead and name these. These are pretty simple. They're things that you're already familiar with. We've gone over them a little bit. So this is a triangle because it has 3 sides. Then we have a quadrilateral, which is 4 sides. Then we have a pentagon, and I'm going to go ahead and write these sideways entirely now. Pentagon. Then we have our hexagon, or 6-sided figure. Then we have our septagon, or heptagon, depending on whether or not you're using the Greek or Latin. We'll write the heptagon here. We have our octagon. And finally, we have what is called a nonagon, or a 9-sided figure. Alright, so those are our polygons, right, up to a 9-sided figure. And each of those have a number of sides. So you have 3 sides here, 4, 5, 6, 7, 8, and 9. Alright, and then let's think about the number of triangles that we can form by taking one of the vertices and connecting it to all other vertices. So for a triangle, that's actually pretty simple. So you've got here, and you have a connection here, and you have a connection here. So let's choose one from our quadrilateral. So from our quadrilateral, you have this line here, you have this line here, and then you're connecting it to the other vertice, so you have another line. So there are actually 3 connections here. And what we see is that now I've split it into a number of triangles, and that's actually going to be 2 triangles. Now we do the same thing for our pentagon. So we trace all lines of connections from one vertice to the other vertices. Alright, so we have that one there. And what we see is that there's actually going to be a pattern that occurs here. I'm going to go ahead and trace these out here. These should be straight lines, so it should form triangles when you actually do this. So you've got that. Alright, and then so on and so forth. And then finally we have our nonagon. Alright, so let's go ahead and look at this and see if we can't find some pattern that's occurring here. Alright, so for number of triangles. So obviously a triangle only has one triangle that appears. But then we move on to the quadrilateral, we form those lines between the vertices, and we see that there are 2 triangles that are formed. Then for the pentagon, there are 3 triangles formed. Then we see here that hexagon is going to be 4, and we see a pattern develop here. So if we count the number of triangles, what we see is that for every n side, right, you're going to have n minus 2 number of triangles. So now let's talk about the sum of the interior angles measures. Well, we know that every single triangle has to add up to 180 degrees. So for a triangle, the sum of the interior angles is 180 degrees. Then we have 2 triangles in a quadrilateral, so that's going to be 360 degrees. Then we're going to have 3 triangles, so that's going to be 450 degrees. then 720, and then 900, then 1080, and so on and so forth. And what we see is that the sum of the interior angles is actually going to be the number of those triangles that are formed times 180, because that's the sum of the interior angles of a triangle. So if I want to kind of summarize this result, it becomes my polygon interior angle sum theorem. And that states that the sum of interior angles of a polygon is equal to n minus 2 times 180, and that's it, where n is equal to the number of sides. Alright, so let's go ahead and take a look at some examples of how this can be useful to us when we're looking at a shape or a figure. Alright, so let's for instance take this triangle, and in this triangle we have the angle x, we have the angle y, and we have the angle z. And then inside, in the interior, we have A, we have B, and we have C. Alright, so now we can actually use some of these theorems here to say some things. So, first off, we can say that A plus x is equal to 180. So if I'm given an A value, then to find x, I would say x is equal to 180 minus A. Additionally, this same thing will hold for y and b. And similarly, this will hold for z and c. So this is actually an additional corollary on top of the fact that we have angle sum theorem, and that's just the fact that we've got these exterior angles that are going to be supplementary, so we can make some statements with those as well. What's really nice is that because of this sum theorem, we can also make some other statements as well. Alright, now I want to talk about the exterior angles of a figure. So we noticed that we have this x and this a, and they add up and they're supplementary, right? And what we'll see is that adding exterior angles like this, the pairs will always be supplementary, but an interesting fact that occurs is also that x, y, and z here, so x plus y plus z, will be 360 degrees, and that's actually going to hold true for all exterior angles. So let's go ahead and take a look at that. So the sum of the exterior angles then, we can prove is actually going to be 360. And this is pretty simple. So what we see here is that we have x plus y plus z, or the exterior angles, is equal to 180 minus a plus 180 minus b plus 180 minus c. Therefore, we can reduce this and say that x plus y plus z is equal to 540 minus a minus b minus c. And then what we can do is we can say 540 minus a plus b plus c. So we can actually use our distributive property and take out that negative there. So x plus y plus z is equal to 540 minus a plus b plus c. But we know that a plus b plus c, the sum of the interior angles of a triangle, is just 180 degrees. And so we see that x plus y plus z is equal to 540 minus 180. And what we see is that's going to be 360 degrees. So that's your little proof of why this works. That's our sum of the exterior angles theorem. All right, now let's test this. Let's go ahead and test it on a quadrilateral. All right, so let's go through the same process. So you have now A, B, C, and D, and then you have W and X, Y, and Z. And just for training purposes, what we're going to say is that these are going to be angles. All right, and skipping ahead a little bit, we see that X plus A is equal to 180, and so that W, oh man, that's going to be a W right here, guys. W plus A is equal to 180, and then W is equal to 180 minus A. You have X plus B equals 180, and then X is equal to 180 minus B, and so on and so forth. So we see that when we go to actually add all of these together, when I say X plus Y plus W plus Z, we can say that that is going to be equal to, and I'm just going to go ahead and truncate this, we have 180 plus A, minus A, then you have 180 minus B, then 180 minus C, and 180 minus D. So then we see that our sum here is going to be 180 degrees times 4, so that's going to be 720 minus A minus B minus C minus D. However, what we see is that the sum of the interior angles, right, is going to be equal to n minus 2 times 180, or for a quadrilateral, that's going to be 360 degrees. So this is equal to 720 minus 360, or we can say that the sum of these interior angles is going to be equal to 360 degrees. So we see that for a quadrilateral, the sum of those exterior angles is going to be the same as for the triangle. All right, so let's just summarize our results here. So this can actually be, you can use this page as what you just wrote, and then our theorem will be underneath that. So this polygon exterior angle sum theorem is going to be the sum of the exterior angles of a polygon is 360 degrees. All right, so kind of a couple of things going on here. I just want to go back and review. So our first thing that we talked about was the interior angle sum theorem, and that is going to increase over the bigger figure, right? So as we go from a figure with only 3 sides to 4 sides to 5 sides, my sum of my interior angles increases. So the sum of the interior angles will increase over the period. Your exterior angles sum will stay the same. So every figure always has the exterior angles adding to 360 degrees, which is kind of an interesting observation. And we'll see something in this pattern. If you notice, we get more circular as you go along, right? So your exterior angles are going to approach this perfect circle. And we can talk about that result later as well. So what I want you to do now is complete your in-class assignment. So on a separate sheet of paper, complete for a stamp. You want to, for the following polygons, find the sum of the interior angles, the measure of one interior angle, and the measure of one exterior angle. So remember, the interior angles, the sum of the interior angles will increase over time, and we're going to talk about the measure of the exterior angles will always be the sum of 360 degrees. So for a regular 15-sided polygon, remember when we're talking about regular, that means that you're going to have all of your angles and side lengths being the same. So just keep that in mind when you go to do this exercise. And this is a 13 right here. All right, when you're done with that, go ahead and ask me for a stamp, and then we will move on. If you have any questions, let me know. Have a good day.